Says, find the lateral area of a regular hexagonal pyramid. Y'all remember the formula for lateral area? Let's go back and get it. Lateral area is equal to 1/2 PL. Makes this a whole lot easier. Lateral area equals 1/2 PL. And notice that L is cursed at a slant height. P is the perimeter of the base. L is a slant height. Find the lateral area of a regular hexagonal pyramid with a base edge of 9. And that's all the edges because it says it is irregular. And it has a lateral height of 7. So that's easy. Which, by the way, lateral height, let's talk about what a lateral height is. The lateral is a side. Lateral height would be the height of a side, which would be a slant height. So you're just plugging in. The lateral area is equal to 1/2 times the perimeter of the base. Each section is equal to 9. Since there's 6 sections, that's 54 times the slant height. 27 times 7, 140, 189 square centimeters. Pretty easy. There we go. Next formula, surface area. Well, isn't that pretty much the same thing? Notice your formula for surface area. Surface area is equal to 1/2 PL. Well, isn't that the same formula we just had? Plus big B. That's simply the lateral area. What's big B stand for?
Base.
Yeah, that's the base area. So that's how you find surface area. You're going to find the lateral area, and then you're just going to tack on the area of the base. So it's the same formula, so that's where it comes from. Now, the reason I put big B instead of a formula there, this is of a regular pyramid. The bottom of a pyramid could be a square. The bottom of a pyramid could be an equilateral triangle. The bottom of a pyramid could be a hexagon or an octagon. So that's the reason I just put big B, because it kind of encompasses all those different formulas. First problem. Find the surface area of the square pyramid. The square is on the bottom. So find the surface area of the square pyramid. Surface area is equal to, let's find lateral area first. The area of the sides is equal to 1/2 PL, which is 1/2 times the perimeter of the base. Each side of the base is 12, so 12 times 4 is 48. Everybody see where that came from? 12, 12, 12, and 12. Times L, which is the slant height. They don't give you the slant height, which is exactly what we were just discussing.
If there were one on the bottom, you'd say 12.
It sure would. Yeah. They give you this. The whole bottom is 12, which make this 6 and 6. The actual height of the pyramid is 16. From the top straight down to the bottom is 16. So how do we find slant height? Pythagorean theorem. 16, 6, we need the hypotenuse. A squared plus B squared is equal to C squared. So take the square to the other side, type it straight in, and that should give you the slant height, which is, and I think we can simplify that.
That's 7.0.
Well, we could break it down. We'll do that. We'll just leave it at 7.08. So that's 1/2 of 48, which is 24.
My bad, it's 17.08.
So 24 times 17.08. Go ahead and multiply your answer by 24 and tell me your lateral area is about 410.11. Now that's lateral area. If I want surface area is going to equal this lateral area plus, everybody tell me what we're at now. Area of the base, which is a 12 by 12 square, 144. So we don't need a calculator for that. That's 554.11. Surface area is about 554.11 centimeters squared. You're still doing surface area. Area is still, imagine that pyramid with little squares all over it. We're still doing surface area. We're covering it with something. We're painting it. We're doing something to that of that nature. We'll work maybe one more. We won't worry about these because it's the same process. Surface area is going to be your lateral area plus the area of the base, which would be 1/2 times the perimeter. P is the perimeter of the base, which is, well, we don't have the base. We're given the height of this pyramid from top to bottom is 9. We're given that the slant height is 11, which you can go ahead and plug in if you wanted to. And we need to know, well, this is the distance halfway across it. We need to know the distance all the way across it. Way we're going to find it, again, Pythagorean theorem. This is 11. This is 9. So we've got a squared plus b squared equals c squared. To type it straight into your calculator, move 9 squared over and move the square over. 11 squared minus 9 squared, and then take the square root of it. And that will give you x. So 21 minus, that'd be root 40. Let's go ahead. Let's talk about writing it exact. Let's give our answer in exact terms, because like I said, you don't have to use a calculator on the ACT, so the square root of 40, you're not going to know. So what are they going to do? They're going to split it into the square root of 4 times the square root of 10. And they're going to leave it like that. So your the distance across half of the bottom is 2 root 10. So what's the distance all the way across it? 4 root 10. Double that. Multiply this by 2. The only way you can multiply this by 2 is to multiply that by 2. So the distance all the way across the bottom is 4 root 10. That's each side length of the bottom. This is 4 root 10. This is 4 root 10. Now let's see if we can leave this in exact terms. Extra practice for algebra. What's the perimeter? You got 4 of those, right? 4 root 10 plus 4 root 10 plus 4 root 10 plus 4 root 10.
16 root 10.
16 root 10. Times the slant height, which is 11, plus the area of the base. How do you find the area of a square? So we got to do 4 root 10 times 4 root 10. We got to square it. Briley, help me with that. The area of the base will be 4 root 10 times 4 root 10, or 4 root 10 squared. Briley, how do I multiply that together? Any ideas?
It would be 4 times 4.
Perfect. 4 times 4, which is 16, times, you actually do have to multiply root 10 and root 10 also. Does anybody know what root 10 times root 10 is? 10. Square root of 10 times square root of 10. Because here's the thought. Guys, we're not adding these. There's 4 things here, and they're all being multiplied. This is 4 times root 10 times 4 times root 10. 4 times 4 is 16. We can multiply numbers. Root 10 times root 10 is 10. We can multiply that. The area of the base, 160. So there's your new everything plugged in. 1/2 of 6 root 10 is 8 root 10 times 11 is 88 root 10 plus 160. That's exact. Everybody good with exact? But we want approximate now because exact really makes no sense to us. We just have to know how to do it, so we can stick that as an ACT answer. So we type into our calculator 88 times the square root of 10. And we add 160. And we get about 294.28.
You added 60.
Did I? Okay, I did it for this reason. If you look up and you notice that you typed in the wrong thing, I don't know if I've ever showed you this. If you look up and you notice you typed in the wrong thing and you really don't want to type all that in again, I showed you what to do. Right above the enter key, you have what's called entry. If you go to second enter, it types in for you again. So now you can tack on that 0 that you needed, and you get 438.
Yeah, he did that.
I did. 438.28. I messed up on purpose. Find the surface area of the regular pyramid. This is a hexagonal pyramid, and I don't like this. Think about what you got to do to find surface area. And some of you are not going to like what's over here. In order to find surface area, well, you got to find lateral area and you got to add on the area of the base. So the base is a hexagon. How do you find the area of the hexagon?
What's the 36?
Yeah, locally it's a 30, 60, 90, but it's 1/2 apothem times perimeter. So we're gonna have to find the apothem. Which, yeah, they've kind of made it easier on us. It's not too bad there. Yeah, it would be. So, well, let's first off, let's find the lateral area. Surface area is equal to 1/2 times the perimeter times the slant height plus the area of the base. And we'll do this later. That's the area of the base. Let's focus on the lateral area first. 1/2 times the perimeter of the base. Well, that part's easy, isn't it? The perimeter of the base, it has 6 sides. All 6 sides are 5, so that'd be 30. Times the slant height, which is 8. So that part's easy. I think that's 120. Now we've got to tack on big B, which is actually big A right now. The area of the base. To find the area of this bottom, which they've graciously redrawn for us here separately, we're going to have to do 1/2 times the apothem, which we don't have. Since it's a 36, now this will be 5. Since it's a 30, 60, 90, if this, I think they're giving you, yeah, this is 2.5. The hypotenuse will equal, which you don't have to have, but the hypotenuse would be double that. But how do you go from, in a 30, 60, 90, how do you go from short side to apothem? You multiply by root 3. Now what if you didn't know that? Pythagorean theorem. You could find out, you could get the exact same decimal using Pythagorean theorem. So your apothem is 2.5 root 3. So 1/2 times apothem times the perimeter, which is, well, isn't the same perimeter as here. 5 times 6 is 30. Half of 30 is 15. 15 times 2.5 is 37.5. Is that right? Check me on that. So I get 37.5 root 3. If you don't like the whole root 3 stuff, go ahead and type it in as root 3 and get a decimal. Okay. So we now have 1/2 of 8 is 4. 4 times 30 is 120. Plus, does anybody turn that to a decimal yet? 37.5 root 3. Okay. Final answer. Okay, that's fine. What'd you get for a final answer?
184.
And then I'll work backwards. That means that's about 64.95. Right. That way I can just work backwards. So the final surface area is 184.95 centimeters squared. Next, when you're given a triangular pyramid, and it has to be equilateral because as of right now, that's the only thing we can find. The surface area of a regular pyramid. So the bottom is a 6, 6, 6 equilateral triangle. In order to find the surface area, we're going to do the lateral area, 1/2 times P times slant height, plus the area of the base. And the reason I like this problem, I wasn't going to do it, but the reason I like this problem is because let's talk about how to find the area of a 6 by 6, or an area of a triangle that's got all 3 sides of 6. We'll do that later. So we're going to save big B till later. 1/2 times the perimeter of the base. Help me with that, Dylan. Let's see. What's the perimeter of the base? This is good. Base is 6 by 6 by 6, or all 3 sides are 6, so 18. Times the slant height. Slant height is 8. Everybody remember, slant height is how far it is from the top down to an edge, not straight down. It is area of the base. So how, I did P here, perimeter of the base there. So now finding big B, let's come over here and do that. We got two methods. First method, since it's a 6, 6, 6 equilateral triangle, is you could draw a height. That'd be a 3, 3, that's a 30, 60, 90 right triangle. And the height would be, if this is 3 and this is 6, that would be 3 root 3. That's one method. I wanted to remind you of a second method. To find the area of a triangle if you know all the sides, you can use Heron's formula. Semi-perimeter, what do we use for semi-perimeter? What letter? S. Times S minus A times S minus B times S minus C. The perimeter is 18, so the semi-perimeter would be 9 times 9 minus 6 times 9 minus 6 times 9 minus 6. Yep, squared it. Well, actually, if you want to get real technical, 3 to the 5th power. You see all 5 of those 3's? So the square root of 3 to the 5th power, which is the square root of 243. That's got a perfect root in it. I think it's 81. Y'all see that 81 right there? 9 times 9. So you can split that into the square root of 81 times the square root of 3, which is 9 root 3 is the area of the base, which is the same answer you got the other way. So 9 root 3, which now we've got 1/2 times 18 is 9. 9 times 8 is 72 plus 9 root 3. Can't add 72 and 9. That's equal. That's exact, by the way. Approximately, if you do 72 plus 9 root 3, Trace, type that in for me, see what you get. So your surface area is about 87.6, again, since it's area feet squared. So exact and approximate there. And the next one, I'm going to do it just because, honestly, y'all need some extra practice with hexagons, heptagons, octagons, nonagons, all those different gons. So, I guess polygons. You need extra practice, so the surface area of a pyramid is equal to 1/2 PL, which is your lateral area, plus the area of the base. You don't have a slant height, do you? Picture this. I've drawn my pentagon on bottom here. Pentagon has a side length of 4. If I draw a central angle, that central angle, I've got 5 central angles because there's 5 sides, and divide that 360 degrees by 5. Actually, that's the wrong angle there. Divide your 360 degrees by 5, and I believe you get 72 degrees. Each central angle will equal 72 degrees. Which means if I split a central angle in half, like I've done here, that half of the central angle will be 36 degrees. And not only did I split the angle in half, but I also split it since this is an isosceles triangle, I also split the base in half. Now, in order to find, we need a slant height. The slant height, if I drew this right here, well, does everybody understand that the line that I just drew here, what's that called? What kind of line is that? That's an apophysis. In order to find your slant height, you got the height of this is 7. Let me draw this out to the side. I'm drawing it to the side and I'm spinning it some. The height of this thing is 7. The distance from here to here would be the apothem, and we're looking for the distance from here to here, which is your slant height. Let's see where we're going with it. So you're actually going to have to find the apothem before you can find your slant height. So let's go back over here. To find the apothem, which is right here, we're going to do, this is my opposite side from my angle, this is my adjacent side, we're going to use tangent. The tangent of my angle is equal to opposite over adjacent. Everybody good with that? So it would be the tangent of 36 divided by 2.
0.36.
So your apothem is about 0.36. And what I want you to do, and I'm going to take and put it on my calculator, is I want to store that because I'm fixing to use that. Now, did you do 2 divided by 1036?
Yeah. Or 1036 divided by 2.
This is a proportion. Let's try that again. This is a proportion. In order to solve this proportion, you got to do 1 times 2, and then you have to divide by tan 36. So that'll actually be 2 divided by tan 36. 2 divided by tan 36.
2.75.
And see, that seems more reasonable.
Yeah.
Okay, if this is 2, then this will be 2.75, and I'm going to store that. The way you store, if you don't remember, hit your STO button, and I'm going to store that into A for apothem. So my apothem is about 2.76. So let's go up here and put 2.76 in. In order to find my slant height, Pythagorean theorem, A squared plus B squared is equal to C squared. So 7 squared plus that 2.76 squared is equal to your slant height squared. Square the other side. So now, typing that into your calculator, I've got 7. Well, let's go ahead and square the whole thing. The square root of 7 squared plus 2.76 squared, which if you remember is my apothem, so I can just type 8. And you get your slant height is about 7.52. And I'm going to do the same thing. I'm going to store that into alpha B. And let me make note here that I've got the apothem stored in A, and I've got the slant height, which was about, I erased it before I looked. What was the slant height? Anybody's?
7.5.
Well, I can do it like this. If you don't remember what it was, I can just type in alpha B and hit enter. 7.52. And I've got that stored in alpha B, just so I can remember. So now here we go. Now we're set. We've got it. My formula is equal to, surface area is equal to 1/2 times perimeter. That's easy. It's got 5 sides. Each side is 4. What's the perimeter? 20. Times the slant height, which is 7.52. Plus the area of the base. We find the area of the base by doing 1/2 times the apothem times the perimeter, which is 1/2 times, let's put it right here, 1/2 times the apothem, which was about 2.76, times the perimeter, which is again 20. Let's type the whole thing in. We're done. And I've got these numbers here that are rounded. I've got them stored. So we're going to type in 1/2 times 20 times the apothem, right? Or no, slant height, which I stored in B, plus 1/2 times the apothem, which I stored in A, times 20. Enter at 102.75. And that'll be in inches squared. And without writing down which value, this, it's exact. Minus all the stuff that got chopped off, if this kept going, that's my exact answer. I didn't round anything. Since I stored B and A as your slant height and your apothem, those were rounded answers, but when you store them in your calculator, it stores as the exact answer. So that's as close as you're going to get, about 102 3/4. Now let's talk about the lateral area and the surface area of cones. Okay, so we're going to go through and we're going to find the lateral area and surface area. We're nearly finished with lateral and surface area of all these different shapes, and then we're going to find the volume of all these different shapes. Cones and I think cones and spheres is about all we like. And here you see right versus oblique. Just anytime you have oblique, that just means it leans. Okay, and we'll talk more about oblique cones later. Here's the formula for the surface area of a cone, and it's an odd formula. What you've got is when you're dealing with a cone, if you dissect this thing, well, the base is a circle, we know that. But if you take the sides of a cone and you split it, you see it's kind of remember finding the area of a sector? That's what you've got there. You've got a sector. And here's your formula. The lateral area, I'd write down both. The lateral area, the area of the sides of the cone, just the sides, not including the base, is pi r L. The area of the base would be pi r squared. So the surface area, you don't have to write that down. The surface area would be pi r L plus pi r squared. There's your lateral area and your surface area. And hopefully I wrote it like that so you could see that where this comes from is simply the lateral area plus the area of the base. Here we go. First problem. Conical slate roof at the right has a height of 16 feet and it has a radius of 12 feet. And they've done a little cross section. We're talking about cross section. They've done a cross section for you there. We don't have a slant height, but we know how to find slant height. Hang on. 3, 4, 5. That's a triple, right? Multiply everything by 4. 12, 16, 20. This is also a triple. That's good. Similar triangles, it makes it a ton easier. So as I say, find the lateral area. The lateral area is equal to pi r L. These are easy. So pi times r times L. Multiply 20 and 12 together, like terms, you get 240 pi's. Do you want that as approximate? 240 times 3.14.
753.
And that is in feet squared because we're still talking about area. If you wanted surface area, which I don't know why you would in this case, this is a good example of why sometimes you want lateral area, because you're covering just the outside portion of this with tile or with, in this case, I don't know what that is that got it covered with, but with some sort of building material. You're not covering the bottom. The bottom is not even shown here. But if you did want surface area instead of lateral area, you'd simply tack on the area of that circle, pi r squared. Let's go on to this problem. Find the surface area. And again, surface area is equal to, let's split it into two separate problems, pi r L plus pi r squared. The area of the side plus the area of the base. Pretty easy. Pi times radius, and let's leave it exact. My suggestion is leave it exact as long as you can, because then you don't have to deal with decimals, many decimals. What's the radius?
7.4.
That's not a decimal. That's pretty good. Times slant height is 15. Plus pi, and the radius you said was 7.4, right? Now watch me leave it exact. Because like I said, the minute you take pi out and put in 3.14, it's no longer exact. So watch me how I'm going to leave this exact. We're going to do 7.4 times 15, which is?
348.
Shouldn't be that big. 7 times 15 is just...
Oh, I added the pi.
Okay, yeah, not yet. Leave pi. We're going to leave this thing exact. What'd you say? Say it again. 111, that sounds close.
Yeah,
Point.
Yeah.
Point anything? Oh, really? Cool. 111 pi's. Plus, we're good with that. You got 7.4 squared over here. Do that for me.
54.76.
Pi's. You see it's still exact. We've not rounded anything. Add the two pi's together, you get 165.76 pi. Nothing is rounded there. I can use my equal signs. And that's in centimeters squared. If you want the approximate answer, now if you wanted approximate, you could have typed this whole thing straight into your calculator here. Or 165.76 pi. Did you have the exact answer? Or the approximate? 520.75 square centimeters. Okay, here we go. Same thing, let's find the surface area of this. And the reason I wanted to work this is just, I don't know, I don't think we've worked enough with diagram theory problems. I just want to do it just one more time. Okay, just in case somebody here didn't catch the first 178 times. Here you have a height, and you have a radius, but you need a slant height. Notice that it forms, when you have a height, a radius, and needing a slant height, notice it forms a right triangle. To where, which by the way, the 7 is the height here. Our formula for surface area is pi r L, which is the slant height, we're missing it, plus pi r squared. 6, 7 is not a triple. So we're going to have to do 6 squared plus 7 squared equals L squared, square the other side. Say again.
Square root of 85.
Square root of 85. And that will not simplify, by the way. So you have pi times the radius times the square root of 85 plus pi times the radius squared. Let's put our pi's at the end. Well, actually, watch this. There's a little thing, anytime you've got a square root in a problem, they're never going to write any of this stuff outside the square root. They'll never write it out after the square root. So you would actually write this as 6 pi root 85 plus 36 pi. That's how they would write your exact answer. Does anybody know why they wouldn't put pi afterwards? Any idea now why they wouldn't put pi afterwards? Is that pi under the square root or not under the square root? It's not supposed to be under, is it? That's the reason most of the time if you've got a number that's outside the square root, they'll put it here. That way you know for sure that's not under the square root. Okay, so don't write it like that. That's the exact answer. If you want an approximate answer, just type that whole thing in, 6 times pi button times root 85. What'd you get?
286.
And I think that was in inches squared. So here you go. If you haven't written them all down, take a moment. Here's all your formulas.
Yes.
To find the lateral or surface areas, and you can put on your formula sheet. To find the lateral and surface areas of a prism, cylinder, pyramid, and cone, here's lateral areas. And again, like we said a while ago, surface area is simply lateral area plus big B, or the area of the bases. So here's surface area is the same thing plus 2 times the base. Same thing plus 2 times the base, which I would probably write down this surface area formula. Or you can put the Swinford surface area formula, which was C times H plus R. So there's all your different formulas. I'll give you a second to write this down. So now we're done for temporarily with surface area. And we're going to move on to volume. First thing I want you to know is what is volume. And I don't know what this is. We'll read it because I'm interested in those little thermometers. Have you ever saw a Galileo thermometer?
Nope.
Of course, it's got the little bulbs in it. And all depending on what the outside temperature is, certain bulbs will float and others will sink and stuff like that, and you can tell what the temperature is. It says a Galileo thermometer uses floating glass spheres in a cylinder to show the temperature. The lowest floating sphere indicates the temperature. The amount of liquid in each thermometer depends on the height and radius of the cylinder. So you see how that would be related to volume. Guys, volume is the amount of space that either the object occupies or the amount of space that you could fill it with. It's the same thing. I don't know.
I'm glad we invented
It's
modern
pretty
day thermometers.
Yeah. In Galileo's thermometer, the amount of liquid contained in each sphere depended on its size. Recall that the volume, which is what I was just talking about, the volume of a solid is the measure of the amount of space the solid encloses. And you can actually look at it two ways. Like I said, it's how much you could put into this. It's how much you could put inside it, or it's how much space it occupies, because that's the same thing. The volume of a prism. Now, listen real close to what I'm about to do. I can pretty much teach volume in about 2 minutes. Here's your rule for volume. Notice with a prism, let's take a triangular prism. Take a triangular prism, or any kind of prism. What's true about the bases? They're the same. In any kind of prism, the bases are the same. What about a cylinder? What's true about the bases? They're the same. They're both circles. Anytime the bases are the same, and you're wanting to find volume, here's your rule. Volume is equal to find the area of the base and then multiply it by how tall it is. I'll say that again. Anytime the bases are the same, in order to find the volume, find the area of that base and then simply multiply by how tall that object is. Here's why. Imagine you've got this right here. Okay? When you find the area of the base, what you're doing, you're seeing how many squares it would take to cover that base. Well, what we need to know with volume is it's nothing to do with squares. Now we're dealing with cubes. We're dealing with like 1 inch by 1 inch by 1 inch cubes. Before, we were dealing with 1 inch by 1 inch squares. So my method for finding volume here is, see how many of these it would take to cover the bottom. Well, would it not take the same amount of these to cover the bottom? Does that make sense? If you line them up, since the bottom of this is 1 inch by 1 inch, and this is also 1 inch by 1 inch, it would take the same amount of these to cover the bottom. But I want to see how many it would take to fill that. So what you're going to do is first off see how many of these it would take to fill in one layer on the bottom, and then you're going to start doing layers. And you're going to see how many layers tall it is. And let's say that, what if it took 40 cubes to cover the bottom of this? And then we found out that this thing is 5 inches high, so it's going to take 5 layers of 40 to cover it. You see the volume would be whatever the area is times how tall it is. So, again, to make a long story short, if the bottom and the top bases are the same, you'll always do volume is equal to big B times H. And we'll talk about the other ones later. So here we go. This is not sitting on its base. The base of this prism is a triangle. In our head, I would like to find the area of that triangle. Alex, do that for me. What do you get? Yeah, 60. Since the base is a triangle, the area of that base will be 1/2 times not the same base, 1/2 BH, 1/2 times 12 times 10, which is 60. So big B is 60. And then simply multiply by how tall it is. If big B is 60, volume is that same number times however tall it is, so you're going to do 60 times 11, which is 660 cubic centimeters. When you're talking about volume, you're no longer saying how many squares would it take to cover it. You're talking about how many cubes it would take to fill it. Makes sense. It would take 660 cubes. And the way that you did that, it's going to take 60 cubes to cover the bottom of it. And you're going to have 11 rows of 60. 60 on bottom, 11 rows of that. 11 rows of 60 would be 660 total cubes. Next one. We're going to get better at this. Okay. Next one, you've got a pentagonal prism. Yeah, pentagonal prism. So let me get me a pentagon here. The apothem. Well, you know what? I'm not even going to need it, probably. But just in case somebody would like to see it. The apothem of that prism is 3.4. The side length is 5. You see they gave you everything. We're not used to that. They gave you everything that you needed to know to find the area of that base. The area of a pentagon is equal to 1/2 times the apothem times the perimeter. Since the side length is 5 and there's 5 of them, the perimeter would be 25. Like I said, we're not used to that. We're used to them making us find the apothem and making us find the perimeter. Has anybody got that typed in? Because we can do exact on that. Say again.
42.
42.5. That's the area of the base, millimeters squared. That's the area of the base. Since the bottom base is the exact same thing as the top base, it's a prism. And all we have to do is take that area of the base, 42.5, and multiply it times how tall it is, and you've got your answer.
340.
340 cubes it would take to fill that. Next one. Just in case nobody knows Pythagorean theorem. Let me scoot this over. First step is we find the area of the base. Here's the base. It is a triangle. And luckily, is it a right triangle? The base of this triangle is 9, but we don't know how. But we do know that the hypotenuse is 15. Is that a triple? I think we can take 3, 4, 5 and triple all those, right?
Multiply by 3.
Multiply everything by 3, you get 9,
12.
12, and 15. That is a triple. So the area of this base, sounds good. The area is 54. In order to find the volume of this prism, we take the area of that bottom and we multiply it by the height. Colton, if this thing was sitting on its base, how tall would it be? This is the base. This shape here that I've got colored, that's the base of it. Set it up on its base and it's going to be 10 feet tall. Makes sense. So therefore, to find the volume, you take the area of the base, multiply times the height. It would take 540 cubic feet to cover, or excuse me, to fill that shape. I've already told you this. Find the volume of a cylinder. Hey, look, the top and bottoms are the same. Find the area of the base, multiply times how tall it is. That's it. So let's work one of these problems and then we'll probably stop for today. Find the volume to the cylinder at the right. Everybody understands this is not setting on its base. Here is the base. The base is this circle. So to find the volume, first thing we do is find the area of the base. Area is equal to pi r squared. Now you know all these old area formulas. What's the radius of this, Carly? 4.5. Good. So there's how you're going to find the area of the base. You can use your shortcut again. Let's say that 45 times 45, that's 20.25. So that's going to be 20.25 pi. That's the area of the base. In order to find the volume, you're going to take that area and you're going to multiply it by 5. How tall it is. Find the area of the base, multiply how tall it is. And again, that's not setting on its base, but where the height is 5. And that's going to be 101.25 pi.
Yes, 3/8.
318.6.
318.08.
0.086. So about 09 inches cubed.